Good morning.
Good morning.
Stage left, stage right.
Go back, go
Heads cut off.
back a little. I feel like a producer.
You put an X in the board. Good morning, Joe Hughes. I'm from Drexel University. For those of you who don't know where Drexel is, it's in Philadelphia, so on the East Coast. So it's great to be here today. I haven't been in Albuquerque for quite a while, and it's wonderful to be with this audience. As the first speaker of the on the topic of peace engineering, I want to give a very introductory talk and start with some of my own experiences and what brought me into the field of peace engineering. My background is environmental engineering, and my PhD is in environmental engineering, and I've been a faculty member now for over 30 years. But at the last 10 or so, I've been very focused on peace engineering, but it's actually a little bit longer history than that. So if we could go to my next slide, please. 20 years ago right now, I got a telephone call from the government of Angola, which was just emerging from a civil war, asking for some help. And I didn't know what that meant, and I'm not sure that they knew what it meant either. But my first experiences as a, quote, peace engineer, and I'm going to define that very loosely at this stage, was getting off a plane in Angola and being told that they needed help from an engineer to help them create peace. And the combination of engineering and peace was something I had never thought about before. And I was asked over a period of about 10 years working in Angola to take on certain projects through an engineering lens, the way that I see problems as an engineer, and it could then become useful in the creation of a more peaceful country. So one of the examples is here. This is a region of Cabinda, Angola. It was an environmental waste. It was turned into an environmental wasteland. This used to be a very productive mangrove ecosystem. And this scar, which extends for many hundreds of square kilometers, was a focal point of violence. This was a reminder of the war, and it was a reminder of the fact that there had been tremendous damage to the environment as a result of the war. And this was a reason why people kept fighting. My job was to figure out what happened and how to fix it. And that's an engineering problem. Ecosystem restoration is something that environmental engineers do work on. But the design objective here was to create a more peaceful community around this problem areas. It's a very different way of thinking about a problem. Typically, we think about can we construct it? Does the technology exist? What's the budget? All those things that engineers classically work with. But this is the first time I was ever asked for the design to create peace, or to help to create peace. It was one of the most challenging projects I've ever had, and it's set my stage in becoming what I consider myself now, which is no longer an environmental engineer, but a peace engineer. Next slide, please. One of the things I wanted to point out about our approach in this project, and every project I've been involved in ever since, is that we use state-of-the-art technology when we're considering solutions for peace. This is an example of data that was acquired from the space shuttle mapping program that we used for this part of the solution of this ecosystem problem I had up on the screen just in the last slide. We use the state-of-the-art technology, and we try to use the absolute highest computational capabilities possible for the solution of these problems. I bring this up early because many people think of peace or solutions to some of the challenges we're working on as being low technology solutions. And I'd like to change your opinion on that over the course of the next few days. These are too important of a problem to rely on Band-Aids or tape to try to solve them. We need to use the best tools that we have. And this is an example of that here. Next slide, please. So after about 10 years of work in Angola, I was invited to an organization in Washington, D.C. that's called the United States Institute of Peace. And the United States Institute of Peace, their purpose is to support our government in diplomacy in global conflict. And so I was at the United States Institute of Peace, and they said, what we really need are some engineers. We don't have people who understand technology working on peace and helping us to find solutions in a modern context. And this was a light that really came on for the folks at USIP and for myself This was connection was made from the work we've been doing in Angola. Say, let's bring technology to diplomacy and help in the solution of some of the big problems facing our world. Next slide, please. I had some skepticism about this, so I reached out to a person that I had great trust in, but also someone who I thought had a very different feel for the idea of peace. And this is a colleague of mine, General Phil Breedlove. And Phil was at the time I was speaking with him about the concept of peace engineering. He was the Supreme Allied Commander of NATO. So that's the highest ranking military officer in NATO, reports to 30 heads of state. And I talked to him about the idea of peace engineering, and his first response is, I love it, and I'm going to start laughing at you because I know what you're going to say. And he said, you're going to save the world, you're going to solve these problems, you're going to do all these wonderful things, and you'll be laughed out of the room. He said, I love your idea. This is exactly what we need, but you have to have a humble approach. And so we worked on that approach for quite a while and actually published some of it in 2020. But it's very important that we realize that this is not the first time people have thought about big challenges of peace and climate and challenges of our environment and our future. And there have been a number of attempts to solve problems like world peace or hunger or poverty, all those types of problems. And whenever we approach that, we have to approach it with a certain humility to realize that we're not the solution to the problem, but we can help to solve some of these problems or edge ourselves towards a solution to those problems. And it's something that I always want to bring up in my talks when I introduce peace engineering. We are in no way talking about something that solves these problems easily. What we're talking about is a concerted effort to work on deep, challenging problems and try to take small bites out of them and make progress as we go along. Next slide, please. Peace is a wicked problem. Everybody aware of what a wicked problem is?
Yeah.
There's no solution to a wicked problem, right? Go ahead, please. I'd like to have the interaction, please.
There are problems that what you say that don't have solution.
Or the solutions change with time.
Yeah,
The solution today may not be useful tomorrow.
yeah. In
So-
Spanish we say like problemas malditos.
Say that again, please.
Problemas malditos.
Okay, translate.
Like curse. Yeah.
Okay. So peace is a wicked problem. There is no, quote, solution to the idea of peace. And so when we think about wicked problems, what we're thinking about is action and continued action to maintain or promote a solution. And I have an example of a, quote, solution to a wicked problem on my next slide. So one of the problems that we see all over the world are accidents. I slipped and fell the other day. That's an accident, and it's a chance for somebody to get hurt. There are people who spend their engineering life trying to reduce the probability of accidents. Accidents are a wicked problem. They happen, but they don't have to happen frequently. And this is an example of an attempt to solve a wicked problem. This is the deaths by automobile accidents in the United States, starting from 1925 to about 1995. The green line is the miles driven every year in the United States. What we see is a dramatic reduction in death with a dramatic increase in the amount of vehicle miles driven. There is no solution to that problem, although we see continuous improvement on outcome. It's a layering of a whole number of different component solutions to have that effect. We change the way we build cars. We change the safety in the car. We change the way we build the roads. We change how we educate people. We change the signaling on roads. We do all sorts of things that incrementally move this death by vehicular accident to a much, much lower level, despite much more miles being driven. This is an example by analogy of peace engineering. How do we take the world as it exists today, in the top left quadrant, and how do we move it? And Ribeiro, you have an ambitious timeline, but how do we start to change some of the parameters that we would like to measure as outcomes of peace in that incremental layered solution approach? Yes, please.
As to that point, where the lines cross, it also coincide with the policy of the seatbelt in this, at least in this country.
Absolutely.
And that that policy have decreased the mortality due to car accident more than, any others. And so, but at the same time, the industry, when that policy was happened, the car industry was the higher opposition to it. Right now, going back to the definition of climate change, the cars that sell are the cars that have more safety features.
Sure, and seatbelts are a wonderful example of something that made a dramatic impact in this. That seatbelts alone would not have created this. And so it is that idea of added components, and some of them have more weighting than others, but there is no singular solution to the problem. So, but what I wanted to get in this short introduction is the thought of technology as a component of the solution to problems of peace, a component, not a on its own solution. The idea of technology and the idea of layering of solutions for desired outcomes. Next slide, please. So when I think about peace engineering, I think about peace as a design objective. I'm trying to create something the outcome will be a more peaceful engagement. The example I gave from Angola is shown in this kind of classic conflict curve. In the case of Angola, we were working in a system that had already been very violent. It had a long civil war. We were trying to restore from that. So my idea of designing for peace was post-violence in Cabinda. We'd like to be working more and more in other regions of this conflict curve. We'd love to be working on avoiding. Can you imagine the problems that don't happen if we could just avoid them? How much money and lives would we save? Where we see things accelerate, how do we dampen that? That's a different phase. And then when we have to, how do we restore? So, thank you. And when we think about peace engineering, we oftentimes think about these three different domains. Because if you can avoid a problem, it's a very different challenge, or what we work on in avoiding is a very different challenge than we already have the harms that have been done and trying to restore it after the harms have been done. And so this is the example. Most of my work, I have to say, is on this side of the spectrum. I don't get to spend as much time on this as I would like. Hopefully we'll have some chance to talk about those today. Next slide, please. So there's a lot on this slide. I'm going to try to simplify it. When we think about engineering, we think about systems. And systems mean there's lots of parts that come together and create a system, and they interact, and there's outcomes. There's four types of systems in engineering. There's basic systems, complicated systems, chaotic systems, and complex adaptive systems. A basic simple, so these are simple. So the airplane you flew on to get here is a basic system. Some would say that's complicated, but in our terminology, we're going to call that the simplest form. A complicated system is something where human beings start to become pretty involved. So traffic in Albuquerque is an example of a complicated system because it's technology and people together, and people do strange things. There's chaotic systems. This is where there's non-linearity in the mathematics. Weather is an example of a chaotic system. We can't predict weather, but we can forecast it. There's a big difference between prediction and forecast. And that's what we mean in a chaotic system. Where we live in peace engineering, I'm going to start, which is called complex and adaptive systems. Complex and adaptive systems exhibit behaviors that are unpredictable from their parts. They exhibit what we call emergence. Biology is full of emergent properties of complex systems. Peace is an example of that. And in the world of complexities, especially in biology, there's been a huge number of tools that have been developed to help us understand and hopefully forecast the outcomes of complex and adaptive systems. It's because of these types of tools that I believe we actually have an opportunity today to work on the problems of peace that we've never had before. These are all driven by huge data sets. These are all driven by massive computation, but they all have the opportunity to work on this problem, this example of emergence. The simplest possible emergent property I can give to you in daily life is when you ride a bicycle. The bicycle on its own cannot travel. It can't stand up without propping it against something. You can't move at those speeds for those distances on your own. When you combine the two, the bike stands up and you move fast and to where you want to go. That's the simplest form of a human-machine complex system that I can think of. When we think about peace, we're thinking about something vastly more complicated than a bicycle, but the idea of emergence is the same. Next slide, please. Another component of what makes violent or peace engineering a wicked problem, is the definition of violence itself. When we think about violence, many of us will immediately begin to think about what we call direct violence. Direct violence is where there's a harm done. There's a victim and there's a perpetrator. And that's what oftentimes people think about when they think of the term violence. But we need to expand that definition in peace engineering and to think about the other forms of violence that underpin the direct violence that we observe in the world. Structural violence. So these are where institutions create inequities, racism, and other forms of inequities. Cultural violence, whereas a culture, we can rationalize or justify structural or direct violence. By the way, the arts, music, and other arts are full of cultural violence, things that justify acts of violence. And then time violence, we talk about climate change when we're talking about time violence. We would focus on the impacts on future generations. When we start to look at these problems and start looking at them, for example, here on the scale of communities, we start to draw some pretty complicated engineering diagrams of feedback loops and interactions between different elements of our system. This is an example of some work we did on human displacement in Syria and drawing some engineering systems maps of communities and the interactions between them. What we find is there's incredible complexity in even simple communities to try to understand when we think about violence in a community. And for the most part, we don't have information on a lot of these interactions. But one of the real challenges we have today in this new and emerging field of peace engineering is the creation of useful information. We lack information to be able to drive our understanding of these types of interactions. In this case, an issue of human displacement. Next slide, please. Another element that makes this a really interesting area to me, peace engineering, is the types of people who have to come together to talk about solutions. This is some people use the term interdisciplinary. I don't think that's appropriate. This is, I believe, a convergent discipline. Convergence is broader than interdisciplinary. And I show here just engineering in green, social sciences in blue. This is a partial list of what has to come together to form peace engineering. Bruce, I put this here because I will not speak of it with you in the room. However, finance is maybe something we should have at the very core, but I'll leave that for my colleague to discuss today. But the solution or the interactions that have to take place in peace engineering require an amazing cross-section of people. And that's one of the joys of being able to be here today, is to talk to a group of people that I normally wouldn't have a chance to interact with. This is my last slide. And I wanted to give, I have a slide that has my email address on it, but some things that I've developed, my initials are JBH, so that's why it says first principles JBH. Some people may disagree with me on this. When we think about peace engineering and we start our discussions today, I want you to consider these 6 things. Peace, if I were to ask everybody in this room today to write down their definition of peace, I would have every answer being different, but every answer would be correct. Peace has an enormous range of meanings and definitions, and it's a very complicated thing to talk about because you never know if you're talking about the same thing with somebody else. And I hope we get to engage in some of that. That would be a nice thing to do. Most people think peace is worthwhile. Most people. Now, that means there's a tremendous interest because most people are interested in peace, but not all. That's important to also consider. Conflict is normal human condition. I'm in conflict with myself. I would love to lose that last 5 pounds. It's driving me crazy. I'm in conflict with myself. That's okay. Doing harm to myself is not okay. And that's a line that we cross when we go from conflict to violence. And I encourage us to embrace that difference. Conflict being a normal human condition, violence being something that we should avoid. Engineers do not solve problems. Engineers create artifacts and tools for others to solve problems. Let me give an example. You do not want an engineer to operate on you when you have a malady in a hospital. You want a doctor to do that. But you want that doctor to have really good tools so that your surgery is successful. The tool is created by the engineer. The surgery is done by the doctor. And so when engineers work on the idea of peace, it's important to recognize that the engineers will not be the actual delivery of a peaceful solution, but we can help others to do a better job of it, improve their capabilities. And the last one, which I've adopted very recently, Ramiro, and I think I may have gotten this from you. If nothing changes, nothing changes. And I think most of us realize that the future is giving us challenges for which we will need to adapt. If we don't change, nothing will change. So with that, my last slide. If you've never had a chance to go on YouTube and listen to John Kennedy, one of our presidents who was assassinated in 1963, John Kennedy gave one of the best descriptions of peace engineering you'll ever hear in an address on YouTube that he had in June of 1963. This is part of his speech. The first 10 minutes of that speech will tell you what peace engineering is. He spoke about it in 1963. My email address is on the bottom. I hope I get a chance to interact with everybody who's here today. And those of you who are logging in, I hope I take some questions. Thank you for your attention. And I hope that introduced the subject and got us going this morning.
Few questions, and then when we have the break, we're gonna have a discussion and hear from you. We need your feedback.
I do have a question, and thank you for your presentation.
Good morning.
Good morning. You talked about incorporating new tools and technologies to solve problems, and that engineers create those, and then maybe other people like policymakers use them. Are engineers the one that suggest how to use those technologies? Is there a joint and cooperative job, like the how to implement those tools and technologies?
It's a fantastic question. So the problem that we have in engineering is we don't know what the policymaker needs. And so when I work with people in this area, I ask them how I can make their life better. Where could you be more efficient? What information don't you have? I start to ask those kinds of questions because that makes me think of the tools that we can develop to support that person. This approach really comes from biomedical engineering, where engineers, I said we, being an engineer, didn't know what doctors needed in the operating room to do a better job. And it wasn't until engineers went and sat in the operating room, they realized, oh, wait, that could be better, that could be better. From a tools perspective, and started adding tools to what doctors could use. I don't know what policymakers need. I can kind of think of my own ideas and think, boy, this will be great for the policymakers. They may look at me and say, that's the last thing I need. So what's really important is for engineers and people who make tools, you hear from people, what would change my approach to something? What would make my ability to do my job better? And that gives us ideas to go back into our little laboratories and try to create things. But it really, that communication, it starts with talking at the engineer, and then ideally the engineer has some questions and we start to iterate. Does that help?
Yes. Hello.
Yes.
I was going to ask, like, from what I'm seeing, it seems like engineers can interact in the process in two ways. On one hand, you like see how to understand a very complex problem like a conflict is, and on the other hand, you design tools to address that problem. So on the first side, on the complexity of this and those maps you saw, like I'm doing a master's and I'm specializing in conflict, and we've seen a lot about this new tools of using machine learning and social networks to predict and forecast conflict. And one thing that has been very prominent is that we have a very complex system on trying to predict something very specific, like migration or the climate change impacting conflict. And what we see is that sometimes it's very difficult to like connect that complexity in choosing something from that whole bunch of problems and how to go from there to what tool we're going to use to address which one of those things. So my question would be, as an engineer, are you the one who, from your experience, selects which one of those causes is more important or which ones needs to be addressed first, seeing that it's such a complex system of problems that interact in this?
So my first reaction to this is that I would like to be developing something that you would interact with and make decisions with. So in this regard, I would see our role as decision support
Okay.
and creating ideally a visualization environment where you and others could see the same things happening and you could be changing different variables and trying to assess different outcomes. That's an ideal
Yeah.
forecasting.
Yeah.
Visualization is very important. We
Yeah.
have conflict or violence because you need eyes, not ears,
Yeah.
to understand it, so that everybody sees the same thing. So visualization environments are something we think are very important in engineering, peace engineering applications. But the idea something we propose are visualization environments for community conflict or community violence, where people could say, well, what if we changed something in our community? What would be the response?
Yeah.
And we call that forecasting because I don't think prediction is ever going to be possible. But the idea that you have that in these very communities are complicated and you worry about making a change. Are you going to make it worse? Are you going to make it better? What outcome wouldn't we anticipate in some other part of our community? And what we're trying to develop are approaches that give some tools for that. But the idea for us would be to say, here, how does it work? Okay, it's not perfect. Let's go back and start working on it some more and iterate with that and develop those kinds of techniques. I'm the wrong person to make those decisions. I'm probably a decent person to do some of the math, right? But that's just differences in skill sets and experience and those kinds of things.
Makes sense.
Helpful?
Yeah, completely. Thank you.
Thank you, Joe.
Sure.
Oh, I.
Okay, yes.
I was thinking about, when you told us that, scientists and engineers, many times design some technologies and they do it like kind of in a neutral way in which the user will decide either to use it for peace or for other purposes because they only develop what's made. I was thinking, this is what you think in general about technology or science or the ones that are aimed for peace engineering, because I can think of some things, for example, that have been developed, which are like very likely not for peace engineering. For example, it's very hard to sustain that. For example, weapon making, it's neutral and that it is the user that the one who is using it, not for peace. And there are such other stuff which are like very, very ideal for peace engineering. So is it like in general, you sustain that technology is neutral and it all depends on the user, or the other way around? Because it is also important, for example, who finances the technologies that engineers make. So yes, I can understand that in some technologies they might be neutral, but I don't buy it as a general conception.
I thank you. So one of the reasons on my first principles, I said most people are interested in peace and not all people, is because there are people who are not interested in peace and will weaponize things that even you don't anticipate being weaponized. Very few engineers ever thought social media could have a downside. Well, it could be wrong about communicating. A lot. Right?
Yes.
And so The idea that technology is neutral is incredibly naive. It will be weaponized. And so in the development of it, one has to consider that. And that's exactly why I put on the slide, most people are interested in peace, which means it's a big market. There's also the people who will use it in a nefarious way for the opposite outcomes. It's a very important part of any discussion.
Okay, thank you.
Thank you.